This L-shaped solid object is lying in the first quadrant. We'll see how to draw its front, top and side orthogonal views. So, first draw a horizontal reference line XY. Then a rectangle is drawn above XY line. Next, draw a line at a height of h units. The rectangle 1, 2, 4, 3 is the front view of the horizontal L-shaped stem of the object. This is the front orthogonal view of the object. Now, let's construct the top view. As we can see, it is a rectangle of dimensions L by W. We extend vertical projectors below line XY. Then a line 9, 10 is drawn below and parallel to the reference line XY. Next, draw the lines 9, 3 and 10, 4 equal to the length L and join line 3, 4. This rectangle is the required top view. Now, the object is viewed from the left side. So, we can see the L-shaped image on the auxiliary plane. This view appears adjacent and to the right of front view. First, draw a vertical reference line MN which intersects the line XY at point P. From point P, a construction line is drawn, inclined at 45 degrees in the fourth quadrant. This line is used for transferring distances across different views. Now, draw projectors from the corner points of the top view to meet this inclined line at 10', 12' and 4'. Next, from front view, draw horizontal projectors parallel to the line XY. From points 10', 12' and 4', vertical projectors are drawn upwards to meet these horizontal projectors. Join intersecting points to form the side view. This is the complete set of orthogonal views of this object. Finally, draw the first angle projection symbol at the right bottom corner. My friends, let's now create orthogonal views of this machine bracket as seen in the direction of the arrow. So, draw a horizontal reference line XY. Observe, from front side, the bracket appears to be a rectangular slot of size 100 mm by 70 mm and its thickness is 15 mm each on the each side. Now, on the top of this rectangular slot, there is a hollow cylindrical block of diameter 60 mm which appears as a rectangle of 60 mm by 20 mm. The cylindrical block has inner diameter. There is a through hole of diameter 30 mm. These parts are shown with dotted lines as they are hidden in front view. So this completes the front view of the bracket. Now, to construct the top view, project all details from front view below reference line XY. Draw a vertical center line from the center of the rectangular slot. The top view of the rectangular slot appears as a rectangle of size 100 mm by 80 mm. Here we can clearly see the holes in the center of the rectangle. These holes are drawn taking the common center point on vertical center line. The two holes on the fillets are not visible, so they are projected as dotted lines. This completes the top view of the bracket. So let's draw the side view by projecting the details from front view and top views. Don't forget to give necessary dimensions. So that was simple, wasn't it? Now you know all the necessary techniques and theory behind orthogonal views of objects.
Hello, today we will generate front view, top view and left hand side view of this object as seen in direction X. As the first step, we will draw the bounding box of this object and determine bounding rectangles of projections in their respective planes. Observe primary parts of this object: base plate with spot holes, semi-cylindrical extrusion, boss hole, rib and slotted vertical plate. Now let us start with the front view, and we will first draw the rectangle for the base plate 170 mm by 15 mm. Then draw three vertical center lines at a distance of 20 mm, 75 mm and 40 mm from the left side. As next step, we will project spot face holes. Observe each hole has two parts with different diameters. Draw hidden lines for the upper part with 30 mm diameter and it is 5 mm deep. The lower part has diameter of 15 mm. Now let's project semi-cylindrical extrusion. To determine its center, draw horizontal center line 35 mm above the ground. Let us take cross section of this line with third center line and draw a circle of radius 10 mm and semicircle of radius 20 mm. Now complete this extruded part. Next, draw horizontal center line parallel to previous line at a distance of 60 mm upside. Use the crossing point of this horizontal line with the third vertical center line as a center of boss circle. Draw inner circle of diameter 10 mm and outer circle of 25 mm. And don't forget the connecting rib. In next step, draw inclined line with 30-degree angle with respect to the third vertical center line. Taking radius as 50 mm plus 7 mm plus 8 mm, draw semicircular center line that intersects with both the center lines. Now quickly close the end caps of the slot. They have radii of 8 mm inside and 15 mm outside. Now let's go to the rounded corner of vertical plate. It has a radius of 20 mm. Join it with a tangent line that extends till the base plate. As a last step of front view, draw inclined rib at 15-degree angle and connecting the slot. So here is the complete front view. Let us now move to the top view. We see the bounding rectangle here. Next, draw 3 vertical center lines at 20 mm, 75 mm and 40 mm respectively from left. Also, draw a horizontal center line at 20 mm above the base. Note the intersection points of this line with vertical center lines. Using these intersection points, draw 2 spot face holes with 30 mm diameter of outside circle and 15 mm diameter of inside circle. Now for inclined rib and slot, take reference from the front view. The inclined rib is 10 mm thick and slot portion is 15 mm thick. Next, project semi-cylindrical extrusion. It is represented as a rectangle of 35 mm by 40 mm. Don't forget hidden lines for the 20 mm hole in it. Observe this acute overlap of slot with this semi-cylindrical portion as seen in the top view. Then project boss hole as a rectangle of 25 mm by 5 mm and draw hidden lines for 10 mm diameter hole in it. Finally draw projection for the connecting rib. Alright, so let us now move to the left hand side view. First, extend details of base plate from front view and top view. Include lines of spot face holes as well. Next, extend inclined rib and slotted vertical plate from front view and top view. Include through slot as well. Also, take center line of boss hole from front view and generate bossing with its inside hole with hidden lines. Now extend semi-cylindrical extrusion from front view and top view. Don't forget its hole that is throughout the vertical plate. The last remaining part of this object is the connecting rib. Draw inclined line for it. And here we go. So let's show all the necessary dimensions in all the views to complete this solution.
Hi friends, let's start with actual construction of orthogonal projections of points, lines and planes. First, we'll study the projection of simplest geometrical element as a point. So, let's start with an example. Here, a point object A is located in the first quadrant at a height of h units above HP and distance of d units in front of VP. An observer is looking at the point in the direction of the arrow. The front view will be a point A dash on VP and its top view will be A on HP obtained by projectors drawn from the given point A. So, let's draw this projection onto a paper considering the HP is rotated in the clockwise direction by 90 degrees so that it becomes coplanar with the VP. For this, draw a horizontal reference line XY. Mark a point C anywhere on line XY. From point C, mark a point A dash at a distance of h units above line XY and point A at a distance d units below line XY in line with A dash. Here, A and A dash represent the images of the object on VP and HP respectively, and the line joining A dash is the projector line and is perpendicular to the reference line XY. Now, let's see what will be the projection of a point in the third quadrant. Observe, the point object A is in the third quadrant at a height of h units below the HP and a distance of d units behind the VP. Then the front view point A will be a point A dash on VP and its top view will be a point A on HP. So friends, now we have seen the visualization of the point. Let's see its construction. We'll repeat the step of drawing a horizontal reference line XY. Then mark a point C anywhere on the line XY. From point C, mark a point A dash at a distance of h units below line XY and point A at a distance of d units above line XY. The points A and A dash represent the images of the object on VP and HP respectively. The line joining A dash is the projector line and is perpendicular to the reference line XY. Observe, its front view will be lying below XY and top view will be above XY. Now, look at the screen carefully. This is a special case in which point object R is lying within the vertical plane of the projection VP and above HP. Its front view R will be coinciding with the point object itself and will be located above the reference line XY. Its top view R dash lies on the reference line XY. Similarly, if a point, say A, is lying within the horizontal plane of projection in front of VP, observe its top view A dash and front view A. So friends, now you have got acquainted with the concept of projection of a point in the first and third quadrant. And in the next session, we'll continue similar discussion for lines and planes.